Hello everyone, I am Bihan Chakraborty and today I'll be discussing about call by value and call by reference and how it's implemented in Java. Okay, so let's get into it. So first of all, let me discuss like briefly about call by value and call by reference. Then we will jump into code and see how it works. So suppose I have a function swap. This is the most basic example you will see for call by reference and call by value examples. Okay, so it takes two variables int a and b. Okay, I'm not writing the inner code here, you can get it. Like I have a equals to 10 and b equals to, this is 20. Okay, so if I call this function and pass a and b, like two things can happen. If we use call by value, a and b will remain same. If we print a, it will be 10 and b will be 20. But if we use call by reference, then a will be 20 and b will be 10. Now what is call by value and reference? In call by value, what happens is that the computer takes a, okay, this value, makes a copy of this a and passes that copy to the swap function. Okay, and same goes for b. Okay, right? So in call by value, the original variables are never passed to the functions, but instead a copy is passed. Now whatever we do inside that copy, this original values are never changed. They remain unaffected, because whatever operations we did, we like, if we do a plus plus, a equals to 30, whatever we do here, that is done on the copies. Okay, so in call by value, if we need these modified values, we need to return it, and then we could write that the equals to swap, like that. Okay, so in call by value, this remain unaffected. So that is call by value. Now this is done. Now another, we have call by reference. In reference, obviously these are changed, you can get it from the name. So in call by reference, what happens is that we don't send a copy. What we do is send the address of this variable. Okay, now what do I mean by address here? Whenever we declare a variable in memory, in RAM, we have an address where it is stored, right? Or how can we reference it, right? So we have a 10, we have b 20 stored in the memory at some place, and we have that address. So we have that in memory. Okay, so then whenever we do call by reference, the syntax is a little different. Okay, so I'm writing in, like, I'm not modifying the syntax here. Okay, so and also call by reference is present in C and C++ and not in Java. I'll get into that later. Okay, so in call by reference, we pass the reference or the address to the function. Now this swap function gets the address and not the copies of the values. So using that address, they can refer to memory and get that exact same value. Now they can do whatever they want with the address, right? In the address, they can get the value, they can change the value, they can override that, right? So basically, if we use that original address and change the values there, then these are changed because these are pointing to the same address, and at that address something happened. So that will reflect here as well. Yeah, so if we print a and b, we will get 20 and 10 for call by reference, and for call by value it would have been 10 and 20. Okay, now in Java there is no call by reference. Okay, what happens is that, suppose, like, I'll show you the code later, let me explain it. In Java, whenever we pass a class, suppose I have a class A. Okay, class A, and inside that I have X. So whenever I have a function and and we created, suppose a equals to new a with 5. Okay, so this X becomes 5. Okay, so whenever we pass a, we never pass the like, we cannot, so whenever we pass a, like I said, we can't access the address because Java runs in a virtual machine, so we can't get the direct address from in the of the memory. Okay, so what we do here, if like we can't get the address, but Java can. Like, so Java, what it does, it takes the address, makes a copy of that address. Okay, so suppose the address was 1234 for A. In memory, A was stored, which had address 1234. It makes a copy which is also 1234 and passes that copied address to the function. Okay, so inside that function, if I do A dot, like if I do A dot x equals to 5, or okay, it was 5 already. So if I do it 10, and then if I print here, like after calling function of A, if I print A here, I'll get 10. Why? Because I used this address, right? I used this address and overwritten this member variable's value there. So this behaves like call by reference, but this is not exactly call by reference. Why? In call by reference, if I had written A equals to new A with 20, if I had done this, okay, suppose this line is not there. Okay, if I had done this in call by reference, if I printed A here, A dot x here, if we had printed that, we would have got 20 here, because at that address I'm putting something else, and here we're pointing to the same address, so we would have gotten the new value. But that doesn't happen. Since we are sending the copy of the address here, this is exactly the same like for call by value. So this A here inside the function, this A is a copy of the address. So, and this is an object reference. So in Java, whenever we do this line, okay, new A equals to new A. So A is an object reference that stores the reference of this object, right? So what we're doing here, this A reference was storing 1, 2, 3, 4. Now if we do this, a new object is created in memory with 20. This was 10. This is 20. Oh no, it was 5. This is 20. A new object is created, and which had address, suppose 2, 3, 4, 5. Okay, it has address 2, 3, 4, 5. Now A points to 2, 3, 4, 5 and not 1, 2, 3, 4 anymore. Okay, so now whatever we do with A here, this new object is affected, and this A was pointing to 1, 2, 3, 4, and it keeps pointing to 1, 2, 3, 4, because we never passed the actual reference, we passed a copy of that reference. So that is how, like, you can implement or you can mimic call by reference in Java, but you cannot do it completely because of this, right? This is the limitation. So call by reference is not present in Java, call by value is present. And if we want to implement, like, do this, okay, so if we want to modify x's value here, we need a container class here. So having int x and passing x here, doing this will never change this x's value in this line. Okay, to do that we need a class, a container class, class C. Okay, inside that we need to put that x, we put it here, and then we pass this class, sorry, this object here. Okay, we need to create the object here, and then we need to pass this to the function. Then we can do c dot x equals to something, then we can reflect it here, then we can see the reflection here. So let's check the code. Okay, so here I have a, this is the main class. Okay, so I have an integer variable which has a value of 10. We are printing it, so definitely we will get 10. Then we increment the number, and this is the increment. Okay, so this is the function increment number. It, let me zoom in, I think it's too small. Yeah, so we pass the number and we increment it. Now like I said, this is exactly call by value. So we have an integer variable n, we print it, we get 10, we pass. Now the integer is a class and this is our object reference, remember that. Now we are not using the new keyword here because like this is auto boxing. I'll make videos on that as well. Okay, so this is our object reference, and in memory we have a object, integer object that has 10 in it, and this is storing its reference. Now in increment number I'm passing the object reference. So basically a copy of n's address is passed. Okay, now inside here I'm doing n plus plus. So in plus plus is similar to n equals to n plus 1. These are similar. So basically this object reference had address that can be like 1 2 3 4, and now n plus 1 is a new object is created and that new address is put here because of this assignment operator. That is why it's not anymore pointing to that 1 2 3 4 address, that original address, but it points to a new address now. So whatever we do here, like we could have done n plus plus n equals to 5, n equals to 10, whatever we do here, or instead we can write new integer. Okay, now this is depreciated, but like these are the same things, right? Okay, so whatever we do here, this n pointing to the original address, that never changes. Okay, so this is call by value using primitive variables. Now let's see using a object. This is a class A which has an integer x, and these are the getters and setters of x. So, and this is increment x that takes A and increments its value by 1. Okay, so first of all we are creating a new object. Now this lowercase a stores the object reference of this object in memory. Okay, so I am printing a dot get x. Okay, so let me write a constructor as well. Let me pass 5 here. Okay, if we print here, I get 5. After that I increment a. So what happens? I'm sending the address here, a copy of the address, right? So I'm using the functions now. I'm not using the assignment operator. Assignment operator would have overwritten the address present in this object reference. Okay, so using the same object's reference, I'm modifying the member values value. Okay, I'm incrementing it. So after that, since we used the same address that was here, if we print again, the incremented value will be printed. That is, instead of 5 we will get 6. So let me quickly run it. So 10 10, why 10 was here, then we did n plus plus, which was similar to this, n equals to n plus 1. So we created a new object instead of using that old object. So we lost that object here, that object's address, we lost it here. So we can't modify this anymore. So that is why 10 10 and then 5 and 6, because we didn't change the object's reference here. We use the same object reference and accessed that object in memory and modified that. Okay, so this is all for today. If you have any doubt or queries, please let me know in the comments below. And if you have liked my video, please like and subscribe. And I'll be creating more videos on these core concepts of Java. These are really cool and important to understand. Okay, so make sure to subscribe to my channel to get notifications. And yeah, see you in the next video. Thank you.